A differential equation is an equation with the derivative dy dx in it. They give us information about how the slope of some family behaves at points on the curve.
So a slope field gives us like that visual of how it behaves. So for the equation x, it would be dy over dx equals x squared y. So for each point you on the curve, so for this slope field it's 9 points. So at the point 0, 1, which is here, it would be a slope of 0 because it's 0 squared times 1 is going to be 0. So then you do each point on the 9-point slope field and it gives you the general look of the graph. And the more points you have, the better view of the graph and the slope field.
Okay, so for this, that was the slope fields. Now this is the differential equation. So we're just going to go step by step and give you guys a couple seconds to solve each step before we go to the next one. So we start with dy over dx equals x squared y. And then the next step is, so you divide by y, and then you bring that over here, and it becomes 1 over y equals that x squared stays over there. And then you're going to take the derivative, or the integral of both sides, and we'll give you a second to do that. Okay, and then the next step is 1 over y. When you take the integral of 1 over y, you get ln y. And then the integral of x squared equals x cubed over 3. And then you add plus c, which is a constant. So to get rid of the ln y, you have to put an e, or you have to put ln y to the power, or e to the power of ln y. And then since you do it on this side, you have to do it on the other side as well. So once you take the power of this, the e and the ln cancel out, leaving you with y. And then you have to do e to the x squared, x cubed over 3, and you also have to do e to the c power. That becomes, since c is a constant, you just put it together and it becomes y equals c times e to the power of x cubed over 3. Okay, this is separate integrate solve, but it's with an initial value, x equals 1 and y equals 0. So you start with dy over dx equals x times 3x minus 2. And then you do the same thing that you do for the other separate integrate solve problem, and then go to the next step. So you do integral of dy, and then you can't take anything to the other side, so you just have to do integral of x times 3x minus 2 dx. And then before you can do the integral, you can just distribute the x to 3x minus 2, so that's going to give you 3x squared minus 2x dx. And then once you take the integral of that, you get x cubed minus x squared plus c. So, and then also with the derivative over here, you get, or the integral over there, you get y. So to go to the next step, you gotta figure out what c is to get your final equation. So that's where you plug in your y equals 0 goes here, and then your x equals 1 goes to these two. So that gives you 0 equals 1 cubed minus 1 squared equals, or plus c. And then the ones cancel out and you're left with c equals 0. So now you know your c equals 0, that goes here, so you don't have to put anything in your final equation. It's just y equals x cubed minus x squared.
So this is another example of a slope field and how to solve it. So with the equation dy over dx equals x plus 1, this only has one variable, so all the x's will be the same, so if the x is the same. So for example, so these are our 9 points, and then this is the table you can make. So for when x equals -1, you're going to plug it in, so it would be -1 plus 1, so that's going to give you slope is 0. So for all x equals -1, your slope's going to be 0. When x equals 0, it's going to be 0 plus 1, so your slope will be 1 for all when x equals 1. And then for when x equals 1, 1 plus 1, it will be 2. So your slope's going to be 2 for all when x equals 1. And then you just draw those. So -1, 1, it's going to be 0. -1, 0, 0, -1, -1, 0. 0, 1, it's going to be positive 1. 0, 0 is positive 1. And then you see the pattern here going now to 2. And when you you're drawing these, you just want to make sure there's a difference between each slope.
So part of differential equations is growth and decay, and this is a basic differential equation. With growth and decay, you have k, which is a constant rate, and so it looks like that. And then when you solve it, you take the e exponent, and then it looks like that. And then that's your initial value, and that's your final value. All right. So for the first example, let's say a bank account earns interest at a rate of 5% of the current balance. The initial balance is $1,000. So we want to figure out how much money will be in the account after 17 years. And basically all you gotta do is just plug in the numbers from this equation. Be like 2,000, E, K is 5%, 17 years, and then calculate that, it equals.
Is this normal? It seems scary.
$2,000,
Am I gonna be able to get back out?
$339 and some change. So that's pretty simple for basic growth and decay equations. But occasionally you'll have a fixed rate. And a fixed rate is like if you have a quantity that changes at a rate proportional to the difference between the existing amount of that quantity and some fixed constant, which that might be hard to understand at first. Basically you just add a constant to b and it goes right in there. And then when you solve that equation, you get this. That's just plus b to the original. But an example of this that might help explain it better is the pizza example. You take a pizza out of the oven at 100 degrees Fahrenheit. The room that it's in is 60 degrees, and the pizza cools from 100 to 90 degrees in 10 minutes. You get the final rate at which it cools.
Go.
Okay, so on occasion you might have a growth and decay problem with a fixed constant rate. It's like aside from the actual thing. And when you have that, the equation looks like this. It's just the same as the top equation except minus b. And then y, when you solve that, you just get plus b to the other one. All right, but yeah. So a good example to explain that constant rate is the pizza example. So let's say you take a pizza out of the oven at 100 degrees Fahrenheit. The room it's in is 60 degrees Fahrenheit. And that's like the external fixed B constant component, 60 degrees. And the pizza cools from 100 to 90 degrees in 10 minutes. And then you have to find the rate at which it cools. So, first off, we know that B is equal to 60. But we don't know what our initial value is. And to do that, we just subtract our final value from B, like right there. And then we get C, and C is going to equal 40. B equals 60. And then we just take those numbers, plug them into this equation, and then we're also going to take this value, and use those as these values. Alright, and then using some exponential rules and solving this, you'll get the value of k equals negative 0.029. And that's it for when you have to deal with fixed rate.